All right. I hope now you are able to see.
Yeah.
All right. So today we are going to discuss the architecture of Kafka, which is very important again. And this architecture will give you the entire picture of how the all components interact with each other, where the components are actually located. And these are logical things, okay? Because this, when I'm saying it is logical, it means you will not be actually seeing anything like that, but it is how we have to visualize in our mind that this is the architecture of Kafka. But ultimately, everything will be stored in terms of files in Kafka. Okay, this you have to keep in mind. Everything, whenever we say the data is going into partition, so this is just for pictorial view. All right, so let's get started. So there are actually four big boxes you can see: left, right, middle, and bottom. Okay, so left side we know these are the producers.
Okay.
Right hand side these are the consumers. Bottom is the zookeeper, and center part is Kafka cluster. Okay, so till now we have not talked about the zookeeper. So today we will talk about zookeeper also. What is zookeeper? What is the role of zookeeper in the Kafka? Okay, so first we will again discuss quickly what are the terms which we discussed yesterday and where they actually locate. So producers, I told you yesterday, actually locate. So producers, I told you yesterday, they will generate the data. It can be any real world application. Okay. Example I gave you in the first day itself: Netflix, Hotstar, Uber, okay,
Yeah.
and many such applications. And so producers will generate the data, and data will go to Kafka cluster. So this big box is my Kafka cluster, and you can see there are three brokers: broker 1, broker 2, broker 3. Okay. Now, how each broker will look like? Each broker will have some topics. Each broker will hold some topics. So broker 1 is having topic 1, topic 2. Okay. And similarly, broker 2 is also hosting topic 1, topic 2. Broker 3, similarly, broker 2 is also hosting topic 1, topic 2. Broker 3 is also hosting topic 1, topic 2. Okay. And it could be topic n also. Like it could be n number of topic 1, topic 2, 3, 4, 5, and there is no limit. As per your requirement, you can create n number of topics. Now below we can see there are partitions also: partition A, partition B, partition C. So you can see the broker 1 is holding three partitions: partition A, partition B, partition C. Okay, so what are these partitions? For example, for topic 1, I created three partitions. Okay, so for these three partitions, one of the partition will be stored in some of the broker. Partition will be stored in some of the broker. Similarly, for topic 2 also I created some partition. So one of the partitions will be stored in one of the brokers. Okay. So let's, for example, say there is only one partition in topic 1. Okay. Just assume I have created only one partition in topic 1 and its name is A. Top partition A. Similarly, I have created one more partition in topic 1 only. Its name is B. So basically, there are three partitions I created. So how they will be stored, that I'm going to explain here. So here you can see we are creating the replica of some of the partitions. So some of the partitions. So the main partition, which is leader, that will be stored in broker 1. Okay, and then again for partition B, its leader we are storing in broker 2. It is not getting stored here. Okay, and similarly, leader of partition C will be stored in broker 3. Okay, so basically, if any topic is having any number of partitions, a particular only one partition leader will be stored on the same broker. Other leaders will be stored in some other brokers, right? Any doubt till here? Any kind of confusion?
For one broker, we need to have at least, only one leader. So more than one leader will not be able to create one broker.
Right.
Yeah.
Okay. From replica, we will not do anything. Replica is just for securing or saving your data in case of any disaster.
Yes.
So obviously for each partition there will be one leader. So 3 leaders are there, and remaining partitions we will be having the replicas also. So for partition 1, leader is there, and for partition replicas are also there. So replicas will be stored on some other brokers.
Okay.
So similarly is happening for partition B also, partition C also. So this is how pictorially the distribution of partitions happen. Okay, and obviously
Okay.
and obviously you can see that topics single broker, because partitions are divided into sorry, I was saying topic will never be part of only a single broker. Okay, its partition will be distributed across multiple brokers. That is the thing here. So whenever, again, a very good interview question is which can be asked: where is topic stored? Okay, this is your question. In the Kafka cluster. If someone asks this question, then what will be your answer? Your answer will be topic is divided. You can start like this. Since topic is divided into partition, into one or more partitions, hence these partitions should be stored across multiple brokers, provided in bracket I'm writing if multiple brokers are available.
Okay.
Brokers are available.
Okay.
Okay. Generally, 101% brokers, multiple brokers will be there in the cluster. That is why we are calling the cluster. You will never see in real world that there is only one broker in the cluster. Okay. But in case there is only one broker in the cluster, then everything will remain on the same broker only. Replica, all the replicas as well as leader. Right?
Yes. So number of partitions should be same as the number of topics. We have 3 topics in a broker. There must be at least 3 partitions, right? So
Could you please repeat?
if we have 3 topics in a broker, there must be minimum 3 partitions should be there in a broker, right? So minimum number of partitions should be equal to the number of topics.
So it is like this. So you are saying there are 3 topics, correct?
Yes.
Okay. So obviously topic will be divided into partitions.
Minimum number.
Topic. Your question is how many partitions will be there if there are 3 topics, right?
Yes, yes.
Because obviously,
yes, minimum three partitions should be there.
yes. So yeah, and if it is only one broker, then you will create all the 3 partition on the same machine. But here, Jagdish, I was saying suppose there is only one topic. There are not multiple topics. We need only one topic, so we will, for our application, one topic is sufficient, for example. Okay. And that topic I have divided into 3 partitions. Now, because there is only one broker, then obviously all the partition will reside on the same machine, correct? That is what I was saying.
Okay.
Okay. Let's go ahead further. So this diagram is, this middle part is clear to you. Next, bottom part is zookeeper, which is very, very important. So zookeeper is nothing but it's kind of manager of the Kafka cluster. Okay. So you can see zookeeper is interacting with producer, it is interacting with consumer, and it is also interacting with Kafka. Okay. The difference is communication with Kafka cluster is bidirectional, as you can see arrow, but communication with producer and consumer is unidirectional. Okay, that is the only difference. So why it is unidirectional for producer and consumer, and why it is only bidirectional for Kafka cluster? Because zookeeper will not send any information to producer or consumer. They will have to reach out to the zookeeper if they want any information. Okay. So first, let me explain what is zookeeper. Zookeeper is a management entity in the Kafka cluster. It will manage your Kafka cluster. It will decide who is the leader of the topic, who is the what are the different brokers available in the cluster. In case any new broker comes into the cluster, it will also keep the details of that particular cluster. That's why it is called zookeeper. Okay. So these are the management activities it does. Now producer will produce the data, so they will definitely need to know what are the different brokers available in the cluster. So they will reach out to zookeeper, hey, please give me the details of the cluster, and then zookeeper will provide the details. Similarly, consumer, when it will consume the data, it will ask the zookeeper that this is the data I want, and this particular data I have already consumed, so you can proceed further and give me the latest data, means new data. So again, consumer will interact with zookeeper. So obviously These are the features. First one is used for managing and coordinating Kafka broker. This I explained. It will manage brokers and then notifies producer and consumer about the presence of new broker in the Kafka system or failure of the broker in the Kafka system. So if any new broker comes, as I said, it will inform. If any broker fails, that also will be informed by the zookeeper only. So zookeeper will keep the information about the entire cluster with it. Okay. Third one, upon getting notification, now obviously, see, this is my producer, this is my consumer. Now suppose producer is producing some data and the leader was in broker 1. Okay. So obviously producer will produce the data and send it to broker 1 only, correct?
Yes.
Because it has the leader partition. It cannot send data to broker 2. Now, suppose somehow broker 1 fails here only. In that scenario, what zookeeper will do, immediately it will elect a new leader. Okay. So what will happen? Somehow this partition which is available in this on this broker, those will be shifted here. Okay. On broker 2, right? Because count will remain same. Count you cannot reduce. If there are 3 partitions, then you have to keep the number of partitions same. Yeah. Just broker has crashed, so you have to somehow move all this partition to some other broker. It could be moved to broker 2, it could be moved to broker 3. And after moving those partition to broker 1, broker 2, it will elect who is the leader of that partition. So suppose it moved this partition A, partition B, partition C to broker 3. Then obviously it will elect leader for partition A as broker 3. So, and it will also inform producer that, hey, now you can directly communicate and send your data to broker 3. Okay. So that is the work it does. Yeah. And similarly, while suppose consumer was consuming the data, something wrong happened, broker went down, then zookeeper will inform the consumer that now you please start reading the data from this particular broker because broker 1 is down. Okay. So that is what I was saying. This previous slide I will explain after this. I was skipping it for the time being. So point number 3 is upon getting notification from zookeeper about presence or failure of the broker, producer and consumer take decision and start coordinating their task with some other broker. Clear? Okay. Very simple. Fourth point is Kafka broker leader election can be done by zookeeper. This also I explained. Okay. It will run some algorithm, and on the basis of algorithm, it will decide who will be the leader. Okay, for that particular partition. Generally, a leader will be selected on the basis of various factors. For example, what is the configuration of that machine? If it has sufficient memory to host the partition or not. Suppose already the broker 3 is already having 3 partitions and broker 2 is having 2 partitions. So obviously broker 2 has less load. I'm just giving the example. Who has less load? I'm just giving the example. Currently, all the broker is having 3 partition, but for example, assume that broker 2 is having only 2 partition and broker 3 is having 3 partition. Then in case of failure of broker 1, obviously broker 2 is having less load, right? So these partition will be shifted to broker 2. Yeah. So there will be algorithm written, so that will automatically decide. Last point is stores, topics, configuration and permissions. Now this is very important. So whenever we will create any topic, obviously that information will be with Zookeeper. Okay, it will be stored here.
Okay.
Number of partitions.
Okay.
Number of partitions. How many partitions are there in that topic, that will also be kept here. Okay, and who can access that particular topic? Like suppose producer 1 has to send some data to topic 1. Then it will also go via Zookeeper to check whether it has the permission to access that topic or not. If you don't have permission, then you cannot access or send data to topic 1.
Okay.
So that is what this last point says: configuration and permission. So configuration in the sense number of partition in the topic, and whether you can
Access the topic.
access the topic. Third one could be retention period. Suppose you have configured that topic can store the data. Retention period. Suppose you have configured that topic can store the data for 1 month. So that retention period will also be stored in the Zookeeper.
Okay.
Okay. And fourth could be whether you want acknowledgement from the Kafka cluster or not. So suppose you are the producer and you are sending the data to the topic, and you want the acknowledgement whether the data is sent to topic successfully or not. Okay. So that is not compulsory, but it's up to you. If you want some kind of reliability in your application, then obviously acknowledgement will be a good thing. So producer will be sure that yes, my data is sent. If there is no acknowledgement, then there is no surety that data is sent successfully or not.
Yes, yes.
So acknowledgement also, configuration of acknowledgement for a particular topic, that is also stored in the Zookeeper.
No.
Okay. So metadata is nothing but it actually doesn't do anything. Zookeeper just keeps the information about the cluster, about the producer, about the consumer, right? Basically, to perform all the Kafka operation, you need to know the details about the cluster. So those details are called metadata.
Oh, okay.
Okay. So Zookeeper will basically create the metadata, and that metadata will be used by producer and consumer to know about the status of the cluster.
Okay.
Okay. Now, this decoupling thing I am covering.
The backend data, like that's all.
Sorry, Jagdishan, please repeat.
Yeah, like the backend data.
This decoupling thing I am covering.
The backend data, like that's all.
Sorry, Jagdishan, please repeat.
Yeah, like the backend data, the Kafka clusters backend data. Like,
Yes.
Like how many brokers they have, how many topics they have. That is
Exactly. Exactly.
Okay.
Have you heard of any database? Are you aware of any database?
SQL Server, yeah.
Okay. MS SQL Server or MySQL Server? Okay. Any database. At least you know, right? What is database?
Yes, yes, yes.
Okay. There are various databases in the market like Oracle, Microsoft SQL, MySQL, DB2. So basically databases are used to store the data. So Zookeeper is also kind of database only.
So producers and consumers will query the Zookeeper, or it's like an UI method. So
there will not be any UI. There will not be any UI. Producer and consumer will directly make a call, network call to Zookeeper, and Zookeeper will respond.
Oh, okay.
That everything will happen in the background, and that will be transparent to the user. User will not be able to see any such thing.
Okay.
Okay, that thing is handled by the zookeeper automatically.
Okay.
Okay, so now
So
let.
if producer one, like, can you please move to the previous? Yeah. Like producer one wants to send the data to like now what I'm asking is the producer one will send the data only to broker one, or it can be sent to any broker like broker two or broker three also.
Okay, so I told yesterday that whenever you want to send any data to any topic, you have to find the leader for that particular topic,
Yeah.
and leader will always be part of partition. Okay, so suppose producer one want to send the data to topic two, so
Okay.
you have to find the leader of the partition of topic two.
Okay.
Wherever the partition stored, you will send the data to that particular broker. Okay, and that happens automatically. So what it will do is whenever producer is ready with the data, it will go to the zookeeper. It will say, please give me the IP address of the this particular. So it will, first of all, producer will go to zookeeper, and zookeeper will give details of all the brokers to the producer, and it will also inform that this is the leader of this particular topic. Okay, so zookeeper will say there are two topics or three topics in this cluster. Zookeeper will also inform that these are the leaders of all these topics, and now producer will have to decide which topic it wants to send the data. Okay, if it wants to send leader is on broker 2, like that, so automatically data will be sent to that broker because it has all the details.
Okay.
And same way consumer will also behave. How the data will be going in the partition, that I'll explain in the next slides.
Okay.
But you have to understand only this concept that zookeeper will give the information about topics, partitions, leaders to the producer and consumer.
Okay.
And they can easily reach out to that particular broker.
Yeah. Got it.
Now, what is decoupling? So decoupling is also a very good concept in Kafka because it allows decoupled. Decoupled means they are independent of each other. Okay. Producer don't have to wait for the consumer to consume it. It can keep on sending the data as fast as possible. Okay. And similarly, consumer don't have to worry about how much data producer has produced. It can consume the data at its own speed. If suppose producer is very fast and consumer is very slow, then also Kafka will work properly. If producer is slow and consumer is very fast, then also Kafka will work fine. Okay, because producer and consumer both are independent. They don't have to depend on each other. Okay, so that is my first point. Producer and consumers are decoupled. Okay, now I will ask this question: how they are independent and what makes them independent? This question: how they are independent and what makes them independent? Can you answer this question?
Producers and consumers. Huh?
Yeah, how they are independent, how they are decoupled.
How they are independent means
Yes.
just because of the Kafka cluster they are independent. They might send the
Kafka cluster, but what is the reason? What is the actual reason?
they don't want to get the entire data, they can get the desired data from the cluster. So like if, as you said, any data sent by the producer, there's consumer, they have no idea about it. If they want any data, they can retrieve. So they will be.
Okay, let me explain. They are decoupled means they are independent of each other because they are not directly communicating with each other. Producer will not send the data to consumer. Producer will simply put the data in Kafka cluster. Similarly, when consumer has to consume it will not directly reach to producer. It will consume the data from Kafka cluster. That's why they are independent.
Yeah.
That's why a producer could be faster, because there will be enough buffer here where your data can be stored. There will be TBs of space available because of multiple brokers. And similarly, when consumer consumes it, it can be slow also. It can consume the data very slowly, not an issue, because everything is happening via this mediator. It's called Kafka cluster or broker. Got it?
They are not dependent. Like, yeah. Understand.
Shall we go ahead?
Yes.
Okay. Second one is slow consumer do not affect producers. Already discussed. Add consumers without affecting producers. Okay, we can increase the number of producer and number of consumer without affecting each other. Okay, because again they are not directly connected with each other. So suppose here two producers are there. Here 3 consumers are there. You can add one more consumer. 4 consumer you can do, but it will not impact anything.
Okay.
Failure of consumer does not affect system. Obviously, whenever the consumer will fail, it will not affect your system because data is coming from Kafka cluster.
Okay.
Central about producer and consumer, they can work independently. They can fail. They can recover. It will not cause any harm.
Okay.
So this is also this is a very important thing, decoupling. Kafka provide decoupling of producer and consumers. Let's go ahead now. Bootstrap server. Okay, now it will answer your question. You were asking how the producer will get to know which broker to send the data. Okay, so this is the point. Bootstrap server. So what is Bootstrap server? So we know what is broker, right?
Yeah.
And right.
Yeah.
And obviously Netflix and Uber, these companies will have multiple brokers in their Kafka clusters because these companies are very big. Their software is also very big. There are many subscribers all over the world which are using these applications. Okay. So now assume that a client want to send or receive a message through the Kafka cluster. So that particular client can connect to any broker in the cluster. Correct?
Okay.
It is possible, but that broker doesn't have the leader, then obviously that broker is of no use. Correct?
Yes.
So what I'm trying to say is, this is consumer. This want to consume any data from this Kafka cluster, but data is from partition A, and obviously partition A is stored in broker 1, but consumer does not know about broker 1. It knows only about broker 3 initially I'm saying. So then what will happen is, because all these 3 brokers are connected to each other, so consumer will tell the consumer will ask Zookeeper who are the other connected brokers with broker 3. So Zookeeper will inform consumer that yes, broker 2 and broker 1 are also connected with broker 3. So using broker 3, consumer 1 will also come to know about broker 2 and broker 1, and then finally once it knows about broker 1, it will start consuming data from this partition A leader. Okay, so the main thing which I wanted to highlight here is, even if initially a particular consumer knows about any particular broker, it can easily get the information about other brokers, and then it can start reading or writing the data. The first broker which it is aware of, that is called Bootstrap server.
Okay.
Understood? So a client that want to send or receive messages through the say, initially when we start our the lab sessions and so on session, suppose if I create 2 brokers in the cluster, and even if you have the IP address of only one cluster, you will be able to send the data to other broker also. The lab sessions and so on session. Suppose if I create 2 brokers in the cluster, and even if you have the IP address of only one cluster, you will be able to send the data to other broker also, because the IP address through which you are initially connecting, that will be your Bootstrap server, and using that Bootstrap server you can get the details of other broker also.
Okay. Yeah.
So this term also you remember, Bootstrap server is nothing but it is also a broker, but using Bootstrap server you can reach to the other broker which is hosting the leader partition.
Okay.
And why we need leader partition? Because read write always happens from leader partition. You cannot read write from the replicas. Simple. Any doubt?
No, like a Bootstrap server is a broker which has the metadata of the other brokers
Exactly.
inside the cluster.
Yes.
Okay.
So someone asked you this interview question also, that how the producer consumer will come to know about the other brokers. Initially, suppose you know the IP address of only one broker, but there are 100 brokers in your cluster. So using one broker, how you can send the data to other broker? So this is the answer.
Using Bootstrap server.
Yeah, means that initial broker will be acting as a Bootstrap server that will be having the details of all other brokers. Simple.
Okay. Normally, as a Kafka developer or a Kafka administrator, we work only with the Kafka cluster, right? Or we also work with producers and consumers. Producers and consumers are other applications, right? They will be coming from different source, right?
Yes, you are correct. Producer and consumers are application, and whenever we start talking about Kafka in real world, we will only be interacting with the Kafka cluster.
Okay.
Okay, if you are writing a producer application, you will talk to Kafka cluster. If you are writing a consumer application, you will be talking to Kafka cluster.
Okay.
You can never directly talk to any other application. Okay. Why to make things complicated? You just want to send a data, send it to Kafka. Simple.
Yeah.
Initially, it used to happen like when you want to send something, you have to know about the destination also. But here, my ultimate destination is Kafka cluster. That's it. Okay. Next, let's go ahead. If you don't have any other questions.
If you want to insert some data in topics and all, it won't be possible, right? Only the producer will insert the data. We can't insert any data into topic.
Yes, you are correct. Good question. See, Kafka cluster is not a database. Yes, you are correct. Good question. See, Kafka cluster is not a database. Okay, it's not the database where you can directly go and insert the data. Kafka cluster is a kind of mediator where you can send the data using producer only. So you have to write an application. Okay, that is the first option. Another option is there is console also, some APIs also. So using those commands, you can send the data, but directly you cannot insert anything.
So yeah, so the producer needs some kind of format like this topic, this partition, and this. So they have some particular format, right?
Yes, producer
Format, right?
Yes, producer need to know only the topic. Producer will never specify the partition. Partition will be automatically selected by the Kafka.
Oh, okay.
Okay, because partition is very, suppose there are 1,000 partition of topic, for example. Then how producer will come to know which partition, where it is stored, which broker it is stored. So no, producer will only specify two things: IP address of the broker and name of the topic. That's it, nothing else.
The remaining will be the automated process.
Yes.
Okay.
Anything else? Otherwise, we'll go ahead.
Yeah, we can go ahead.
Okay. Topics we have already discussed. So again, I'm repeating here, topics is nothing but it is responsible for only one type of messages. If you want another category of messages, you should ideally create a second topic.
Okay. Yesterday I went through some sources like topic is nothing but a table database. It's similar to that.
Yes, correct. It's kind of a database table only, like one table stores only one type of data. Similarly, one topic will store only one type of data.
Okay.
So if I take an example, suppose there is employee table in the database. So in employee table, you cannot insert the car details, correct?
Yes.
So similarly, in one topic, you cannot insert other type of data.
Yeah.
So that is why we are saying categorize message into group. Kafka cluster, they will decide how many topics they need, and accordingly they will decide. And then there is a relation of end-to-end between producer and topic. Okay. End-to-end means one producer can produce data to n number of topics, and similarly, one topic can send the data to n number of producers. Or you can say one topic can be connected to n number of producers. Okay, I'm repeating again. One producer can send data to more than one topics, and vice versa is also true. One topic is connected to more than one producers. That is why we are saying end-to-end relation. One topic is connected to more than one producers. That is why we are saying end-to-end relation. And last point is very simple. There can be unlimited number of topics. As per your requirement, you can create a number of topics. No one is going to stop you. Okay, but make sure whenever you create a topic, there should be a proper reason of creating that topic. Don't create two topics which is holding the same type of data.
Yeah.
Okay, because that is unnecessary.
Okay.
So this is a just view of topic. So we have created two topics in this Kafka cluster. So blue box is Kafka cluster. There are topic A and topic B. And producer will be able to send data to both the topics, topic A and topic B. And similarly, consumer will also be able to consume data from both the topics. All right.
Okay. Yeah.
Now we are going to deep dive into some more things. So topic we have covered already. Cluster will have topics. Now each topic will have inside that partition. You can see here. So if we see the topic C in more detail, so in this topic C there will be multiple partition. Partition 0, partition 1, partition 2, partition n. And now if we again further go deep into partition also. So each partition will store the data in the form of segment. So there will be segment 0, segment 1, segment 2 and segment n. Okay. So till now we have discussed up till partition only. Now what is segment? So segment is nothing but a file. Okay.
Okay.
Segment is nothing but a you can say you have worked with logs only, right? Logs. So you know whenever we write a log, there will be a file and there will be text added to that particular file continuously. That is the log, right? Nothing else. So if application is running for 24/7, then that file will keep on inserting the data one after the other, correct? So similarly, in partition also there will partition is basically it's a log file, and inside that we will be keep on adding the data. So first data will go at the top level, second data will be added to the next to it, third data will be coming, that will be appended next to it, right?
Okay.
So similarly in partition, whenever we will send any data, those will be appended one after the other. So first data will go as segment 0, second data will go as segment 1, third data will go as segment 2, like that.
Okay.
So that is how you can assume that partition is kind of a log file, and inside that log file, whenever you write a data, so each data will go to a particular location. That location is called segment.
Right, got it.
Got it?
Right, got it.
Got it? So this is another view. So for example, this is broker. These are my partition inside that broker. So this is first topic. Colors are also mentioned. So topic A, topic B, topic C. These are my three topics. Green color topic is topic A. This orange color topic is topic B, and this is blue one, which is topic C. So now you can easily see topic is having three partition, right? Similarly, topic B is also having three partition. Topic C is also having three partition.
Yes.
Okay, and how many brokers are there? There are 4 brokers. Name is 101, 102, 103, 104. Okay. And now we also know that broker 1 is hosting 2 partition. Partition 0 of topic A and partition 2 of topic C. Broker 102 is hosting 3 partition. Partition 1 of topic A, partition 2 of topic B, and partition 0 of topic C.
Okay.
and likewise broker 103 and 104. So here you can see some brokers are having more partition and some broker are having less partition. Okay. So currently, which broker is completely occupied or more loaded?
Second, 102.
102, correct? And other brokers are not having that much load because they are hosting only 2 partitions. Okay. Okay. Suppose number of partition are 3 for any topic, but number of brokers are 4. So now whenever you distribute the partitions, obviously some broker will have more partitions, some broker will have less number of partitions. So that is also fine. That is completely fine. It can happen. Now we were talking about the segments. So I'm talking about this broker 3, which is here mentioned in this big rectangle. So this is our orange one is partition 0, as you can see here, and this one is our partition 1. Now I was saying that partition will store the segment. So segment 0, segment 1, segment 2. Similarly, segment 0, segment 1, segment 2, similarly, segment 0, segment 1, segment 2, segment 3. So what will happen is, like this is the data actually. I told you, right? These are the whenever you write anything to a topic, it will go inside the partition, and inside partition it will go inside the segment. So this is how the data will be stored. And this 0, 1, 2, 3, this numbering shows that there will be a sequence always in the partition. So whatever data goes first inside the partition, that will be assigned a number 0.
Okay.
After that, second data will be going at position 1. Third data will be going at position 2. So there will always be a sequence of data in a particular partition.
This will keep on increasing like...
yes.
This will keep on increasing like...
yes.
No first come, first out. No such
Exactly.
thing. Okay.
Exactly. So whenever consumer will consume, first consumer will consume only segment 0, then it will consume segment 1, then it will consume segment 2.
Okay, got it.
Okay. So make sure whenever you want the consumer to consume the data sequentially, in that case you have to send all the data to a single partition. So I was explaining you how the log file works. So this is the pictorial view of that log file. Suppose this box is my log file. So whenever I'll write anything, it will go first initially at 0 position. Then second line will be written at position number 1. Same concept is applicable in partition also. Whenever you send any data, you write any data, it will be appended at the end only.
Okay.
Clear? And when any consumer will read it, it will read from that particular file sequentially only. Okay. So suppose there are 2 consumers, consumer A, consumer B. Here I am telling them as destination A and destination B. Okay. So if they are reading it, then suppose consumer 1 is reading it at position number 4. Then next item it will read will be 5. Okay.
Okay.
Similarly, if consumer B is reading currently from position number 10, then next item it can read is 11. Okay. So reading and writing, this is how it happens in partition.
Okay.
Now, obviously, whenever read or write will happen, whatever is the less number, that shows the past data, and whatever is the greater number, that shows the
Current.
recent data, current data. Okay. So number 0 is the first data or the past data, and the number n is the present data, and n plus 1, n plus 2, n plus 3, these will be written in future, obviously. So remember this thing, that Kafka works on the principle of log file only.
Okay.
How we write the data in a log file, similarly data is written in the partition. So that's it for now. You can ask any question if you have. Any kind of question which you can recall, you can ask me.
No. It's fine. We'll go through the video also.
Okay. I'll share this slide also, so you go with this. And you can ask question tomorrow also, if not today possible. Just note down all your questions and you can ask me.
Sure.
Why I'm focusing on the question? Because questions, when you ask, that will increase your understanding. Simply by reading it, it will not benefit you. So just keep on reading again and reading it, it will not benefit you. So just keep on reading again and again any particular slide, go through it 3-4 times and then ask questions. Definitely you will come up with few questions.
Yes.
Okay.
Yeah. Thank you, sir.